Question 12. The cross-section of an arched entrance into the ballroom of a hotel is in the shape of a parabola. This cross-section can be modeled by part of the graph y equals negative 1.6x squared plus 4.48x, where y is the height of the archway in meters at a horizontal distance x meters from the point O in the bottom corner of the archway. Okay. Part A asks us to determine an equation for the axis of symmetry of the parabola that models the archway. All right, so let's highlight our model function. Okay, so there we go, and we're being asked to find the axis of symmetry. Now, effectively, the axis of symmetry is the equation of the line that goes directly in the middle of the parabola. And it basically cuts it in half. So that would be more or less that line. I know that's not perfect, but yeah, it'd be more or less around there. So we've got to find what this value here of x is, okay? And you do have a formula in your formula booklet for the axis of symmetry, and I have written that down here, okay? So it is x is equal to negative b divided by 2a, all right? And so in our circumstance here, we have a is equal to negative 1.6 and b is equal to 4.48. And so therefore, the axis of symmetry is going to be x is equal to negative 4.48 over 2 times by negative 1.6, which will turn out to be 4.48 divided by 3.2, or negative 4.48 divided by negative 3.2, same thing. And that comes to, therefore, 1.4. So x is equal to 1.4 is the axis of symmetry. All right, let's move on to part B. Okay, what we got? To prepare an event, a square-based crate that is 1.6 meters wide and 2 meters high is to be moved through the archway into the ballroom. The crate must remain upright while it is being moved. Determine whether the crate will fit through the archway. Justify your answer. Okay, cool. So we're told that this crate is 1.6 meters wide and 2 meters high. Okay, so we're going to be graphing on our calculator. All right, but before we do that, I just want to sort of illustrate what we're going to be doing. Okay, so we're going to graph our graph, negative 1.6 x squared plus 4.48 x, and we'll get the same shape as this here. Okay, then we're also going to graph the line y equals 2, which is going to sort of draw a horizontal line across the ballroom at a height of 2 meters. Okay, so let's say if that was, let's say roughly that's going to be here. Okay, let's say that's roughly there, and we'll say that this is at 2 meters. Now, if the difference in x from this point here to this point here, how about we call this x1 and x2? Now, if x2 minus x1 is more than 1.6, okay, so aka more than the width of the crate, then we're good, okay? Therefore, crate fits. Okay, and if it doesn't, okay, so if we bring this down and we say it is less than 1.6, also we'll write crate doesn't fit. Okay, and so then that will be our conclusion. All right, so let's go find this out, and I'm going to bring you over to Desmos. It's slightly easier to visualize, but do find out how to do these graphs and find these intercepts in your own calculator. Okay, so Okay, here we are. And so our graph is 1.6 x squared plus 4.48 x. Now, we're not concerned about, obviously, it going below the x-axis. In fact, we can get rid of that. We'll go for y is more than 0. Oh, more than 0. Yeah, we need to do that. And then put y equals here, right? Yeah, there we go. All right, cool. So there we have our archway drawn. And now we're going to draw the line of y equals 2, which is going to be like a horizontal line across at 2 meters from the in the ballroom. And now we're going to have a look at these intersections. So we've got 0.5572 and 2.243. All right, if we zoom in on Desmos, you get more decimal places. So 0.5574 and 2.2426. All right, so if we come back to the pad, I'll write this in. Okay, so intersections. Hold on, we'll write this. So find intersections find x-intersections of y equals 2 and y is equal to negative 1.6 x squared plus 4.48. Sorry, 4.48 x. Okay, and so we'll say the intersection points here, and we'll go into, let's go into red. Are 0.5574, comma 2 and 2.2426, comma 2. All right, and so here we have, let's call this x1. Let's say this is x2. All right, and so then we're going to say, so x2 minus x, oh no, hold on, let's actually write in the numbers. So therefore 2.2426 subtract 0.5574. Let's find what this is equal to. We need a different calculator, bear with me. I'll use this one. 2.2426 subtract 0.5574. So that gives us 1.6852. 0.6852, which is greater than 1.6, okay, which we set up above, all right, up here. So that is greater than 1.6 meters, okay, so therefore we will conclude the crate will fit. All right, and so that is the answer to part B. And I thought it could be interesting to actually visualize this, the crate fitting through in Desmos. So what we'll do is we'll come back to our graph. Okay, let's zoom out a tad if it wants to do that for me. Okay, how kind. I've lost my mouse. There we go. Okay, cool. Now what we can say, if we were to go from 0.6 to 2.2, that would have a width of 1.6 meters. So how about we write that in? We'll say y has to be less than 2 meters, so less than 2 meters, but between this, so from 0.6 x to 2.2, and that is that, and then we'll make sure that y doesn't go below 0, and well, but so it's literally 0.6, beg your pardon. There we go. Okay, and so now you can kind of visually see, this green square here is the crate, which is 2 meters high and has a width of 1.6 meters, and it will, just fit. It's not a lot of wriggle room there, but it does. Okay, so there you go. That is the answer to question 11, question 12, beg your pardon, with a little bit of an extra illustration at the end to show you what it would look like with the crate going through the archway. Okay, there you go.